Okay. Bismillah ar-Rahman ar-Rahim. Now we'll continue. Actually, we'll do now what? We'll do questions from the old exams. Notice, in the old exams, he will not ask you to find the eigenvector for all eigenvalues, for a specific one. So don't need to do these long calculations. He will ask only about one of the eigenvalues. He will ask you maybe about the eigenvalues only. As I said, one eigenvector, I mean, for the eigenvalue. He gave you an eigenvector. He will put something he wants to be sure. Ask about the eigenvalues. So it will be easier, not like in the examples we did, where we find all eigenvalues and all eigenvectors. Okay. So let me check. This one, A, he said he wants an eigenvector only corresponding to lambda equal 2. Only I want it for lambda equal 2. I don't want to add the other things. So I need to I will let V, K1, K2, K3. I need to solve the system A minus lambda I, V equals 0. Let us see what will happen. 3 minus 2, that will be 2. 5 minus 2, 0, 0, 0. Okay. 0, 2, minus 1. Yeah. That will make it easier. I have K1, K2, K3 equal 0, 0, 0. Yeah, I subtract 2 from the diagonals. It's very clear. And the rest are the same. So I have 2K1 plus 5K2 minus 2K3 equals 0. Second row, I have nothing. 2K2 minus K3 equals 0. So I have K3 is 2K2. Okay. K3 is 2K2. Plug it in this one. So we have 2K1 plus 5K2 minus, I put K3, 2K2 minus 4K2 equals 0. So I have 2K1 plus mistake. Yeah, plus K2 is equal to 0. So K1 is equal to what? Minus half K2. So my K2 is the free variable. Since I write K1 and K3 in terms of K2, so I let K2 to be 2. To be a mistake. 251 plus 5K2. And K3 is minus 2K3, so it's minus 4K3. Yeah, this is 1, sorry. 3 minus 2 is 1. This is 0, this is minus 1. So that is K1. So this is K2. So this is K1. So this is K1. So K1 equal minus K2. So let K2 equal 1. So we have what? K1 is minus 1. And K3 is equal to 2. So my V will be what? Minus 1, 1, 2. Which is this one. Easy one. But just be careful about the calculation. This is, I need to subtract 2 from each of these diagonal elements only. So this is 1, not 2. Okay. A basis for R2, which consists of these eigenvectors of this matrix. Okay. So I'll find now it's 2 by 2. Also, if you ask about all the eigenvectors, it's okay. It's 2 by 2, easy one. That will be what? 10 minus lambda minus 8, 6 minus 4 minus lambda. That will be what? Lambda square. 4 lambda minus 10 lambda minus 6 lambda minus 40 plus 48 equal what? Lambda square minus 6 lambda plus 8. And that will be lambda minus 4 times lambda minus 2 equals 0. So I have lambda equal 2 or lambda equal 4. These are the eigenvalues. I need to find the eigenvectors. For lambda equal 2, I have what? What will be the system? I will let V1, K1, K2. I solve this system. So be careful. 10 minus 2, that will be 8 minus 8. This is 6 minus 2 minus 2. That's minus 6. So I have 8K1 minus 8K2 equals 0. And 6K1 minus 6K2 equals 0. Very clear. It's only one equation, which is K1 equal K2. Okay. So I let K1 equal 1 or K2 equal 1. So K1 equal 1. So I have V1, 1. This is one of the answers. Now for lambda equals 4, I let V2 now. K1, K2. I need to solve this. For lambda equal 4. What I have? 10 minus 4, that will be 6 minus 8. And I have 6 minus 4 is also minus 8. So I have actually one equation, very clear. 6K1 minus 8K2 equals 0. So I have 6K1 equal 8K2. K1 will be 4 over 3K2. So I let K2 to be 3. K1 is 4. So my V2 will be 4 and 3. So this will be my answer. But this is V2 and this is V1. So these are the bases. Okay. If the eigenvalues are ordered as follows, then he asks you about add this, subtract this. Who cares? Now we need to find the eigenvalues. That's mainly the idea. So I need just to find the eigenvalues. That will be what? 3 minus lambda, 5, 8, 0, 7 minus lambda, 0, 1, 6, 1 minus lambda. I'll do the expansion with the second row. With this row, cancel this and this. So I have plus minus plus, that will be plus 7 minus lambda times this 3 minus lambda, 8, 1, 1 minus lambda. That will be 7 minus lambda times what? What is this? Lambda square minus 3 minus 4 lambda plus 3 minus 8. So it will be 7 minus lambda. This is minus 5. So it will be lambda minus 5, lambda plus 1 equals 0. So I have lambda equal minus 1, or lambda equal 5, or lambda equal 7. You want to order them. So this is minus 1, this is 5, this is 7. Their product minus 30, wrong. You add them, you get 10. Also, this is wrong. Lambda 1 plus lambda 3, it will be minus 5, wrong. Lambda 1 plus lambda 2, wrong. Lambda 3 minus lambda 2 is equal to 2. That's the correct. Let this, he want only the eigenvector for what? For 3. That's it. So I let V, K1, K2, K3. I solve this system. So I have what? 3, that will be 0. 6 minus 2, 0. Be careful now. 1 minus 3, that is minus 2, 0. 0, 0. This is minus 2. Multiplied by K1, K2, K3. Equal 0, 0, 0. What I have? I have 6K2 minus 2K3 equals 0. Minus 2K2 equals 0. Minus 2K3 equals 0. So you have K2 equals 0. K3 equals 0. K1 is free variable. So let K1 equal 1. So what will my V? 1, 0, 0. Easy one. As I said, the questions in the exam will be easier than the ones in the yeah, which we did. We did everything. Now in the exam they will ask you about one thing, not to find all eigenvectors. like what we did. No, he said the vector is an eigenvector. Sometimes we put these questions, answer true or false, but not anymore. Now we have only multiple choice, but let us do it. This vector is an eigenvector for this matrix. It means what? AV will be lambda V. Let me check AV. Is there a lambda? So this is a multiple of a vector V. So I need to do this 1, 1, 2, 4, 3, 5, minus 1, 0, minus 1 times V. This is minus 1. I have what? 1 plus 2 minus 2, that is 1. Good. 4 plus 6, that is 10, minus 5, that is 5. So now it's impossible. 4 plus 6, 10 minus 5, have minus 1 plus 1, that is 0. So that's impossible to be lambda times a vector like this. So the answer is false. This is not an eigenvector. If K is an eigenvector, he put A there, but he told you this is an eigenvector for lambda equal 0. So you have AV, AK in this case. AK will be lambda K. And lambda is 0, so that will be the 0 vector. So I need to check now this 1, 2, 1, 6 minus 1, 0, minus 1, minus 2, minus 1 times K to find A. That should be equal 0, 0, 0. Let us see what will happen. And to multiply the first row, I have what? 2A minus 12. The second one, I have 6 minus A. The third one, I have 1 plus, this is minus 1. Be careful. So I have 13 minus 1 minus 12 minus 2A. And that will be equal 0, 0, 0. So I have 2A minus 12 equals 0, 6 minus A equals 0, 12 minus 2A equals 0. All of them give me A equals 6. And this is the answer. Is this an eigenvector of this? True or false? Let's check. I need to check A, V equal lambda V. So let me check this. 4, 6, 6, 1, 3, 2, minus 1, minus 4, minus 3 times V. Check what we will get. That will be 12 plus 6 minus 6. That will be 12. 3 plus 3, 6. 6 minus 2, 4. This is minus 3 plus 3 minus 4. Can I write this in terms of this one? 3, 1 minus 1. Yeah, times 4. That will be 12, 4 minus 4. So yes, it's an eigenvector, and this is the eigenvalue. So I have AK, K or B, AK1 equal lambda K1, which is 4 K1. So it's an eigen, so this is correct. I need just the eigenvalues. By the way, in this one, remember we said the trace is equal to the sum of the eigenvalues. If you add these eigenvalues, you cannot get the sum. The trace will be 0. Trace of A will be 5 minus 5 plus 0, which is 0. So this is wrong. This is wrong. This is wrong. So the possibility this or this without solving anything. But now let me do it. 5 minus lambda minus 1, 0, 0, minus 5 minus lambda, 9, 5 minus 1 minus lambda. So I do the expansion for the first row. Who cares? 5 minus lambda. I have what? Minus 5 minus lambda, 9 minus 1 minus lambda, plus 1. Cancel this with this. I have 0, 9, 5 minus lambda. Is it? Yeah. 0, 9, 5 minus lambda. Okay. So what I have 5 minus lambda. This one is what? Lambda square plus 5 lambda minus 9. Okay. And this is what? 0 minus 45. Okay, let me open this. What I will get? Minus lambda cubed. Lambda square comes from where? This is minus 5. Minus 5 lambda square plus 5 lambda square gun. Lambda comes from where? 25 lambda plus 9 lambda plus 34 lambda. Okay. Is it? Be careful. I need to multiply this by 5. This is plus 9. Sorry, this is plus 9. Let me check now. I have lambda square plus 5 lambda plus 9. This is 0 minus 45, correct. This is minus lambda cubed, 5 lambda square, minus 5 lambda square. This is gone. I have minus lambda times 9. This is minus 9 plus 25. That was plus 16 lambda. Okay. And I have what? 45 minus 45. So I have minus, let me take the minus, this is cancelled. So I have, take minus lambda common factor. I have lambda square minus 16, lambda minus 4, lambda plus 4 equals 0. So lambda 0, 4 minus 4, which is this one. The matrix has this. He said one eigenvalue. Let us find the eigenvalues. 2 minus lambda 0, 2. 1 minus lambda 1 half 0 2 minus lambda. I'll do the expansion with the first column, with the second column. So I have 1 minus lambda. We'll do it with this. I have what? 2 minus lambda 2 half 2 minus lambda. That will be what? 1 minus lambda times what? 2 minus lambda square minus 1. So I have 1 minus lambda. This is what? Lambda square minus 4 lambda plus 4 minus 1 minus plus 3. So I have 1 minus lambda and lambda minus 3, lambda minus 1. So what are the lambdas? 1, 1, 3. So I have one eigenvalue multiplicity 1 and one eigenvalue multiplicity 2. That's correct. 3 distinct? No. One eigenvalue multiplicity 3? No. One real and one, no, not real. No real, no. So this is my answer. If B is an eigenvector, he put an A and B. Find A and B. For lambda equal 3. Okay, so I have AV equal 3V. Do the calculation. 201, 121, 102 times V, A1B. That will be what? 2A plus B. That will be what? A plus B plus 2. And the last one, A plus 2B. A plus 2B. That should equal 3 times A1B, which is 3A, 3B. So I have 3 equations, 2 unknowns. We can solve it. 2A plus B equals 3A. So that means A minus B equals 0. Okay. I have A plus B plus 2 equals 3. So that means A plus B equal 1. I can solve this. So I have 2A at these equal 1. So A equal half and B equal half. I check the last one. A plus 2B equals 3B. Is that correct? Yeah, because I'm getting A minus B equals 0, which is correct. So A equal half, B equal half. I have 4 times half plus 2 times half. That will be 2 plus 1, which is 3. So this is my answer. An eigenvectors with lambda equal 9i. Okay, so I'll do the calculation. I will let V equal K1, K2. I will do AV. So I have 0, minus 3. Now, I'll do with the eigenvalue, huh? I'll do A minus lambda I V equals 0 to get the eigenvector. So I have what? Minus 9I minus 3, 27 minus 9I. This is times K1, K2 should equal 0, 0. So I have minus 9I K1 minus 3 K2 equals 0. 27 K2 minus 9I K1, 27 K1 is equal to 0. I note when you put the I in with K1. Okay. You put the I with K1. So I'll lose this one. By the way, it should be the same equation. So if we multiply this by minus 3I or plus 3I, you get what? 27. And this is minus 9I, correct. So this is correct. We have the same equation. So I'll use this one because I notice K1 is the one with the I. So I have 27 K1 equal 9I K2. So K1 will be what? Will be 1 over 3 I K2. So I let K2 to be 3. What will be K1? Will be I. So my vector is I and 3, which is this. Let a basis for what eigenvalue? Lambda equal 1. Okay. So we'll do this. Let V K1, K2, K3. I need to solve A minus lambda I times V equals 0 for lambda equal 1. So what I have 2, 6 minus 2, 0, 0, 0, 0, 0, 0. That times K1, K2, K3 is equal 0, 0, 0. So I have actually one equation, which is K1, 2K1 plus 6K2 plus minus 2K3 equals 0. Can divide by 1 by 2. I have K1 plus 3K2 minus K3 equals 0. Very clear, I can write K1 as K3 minus 3K2. So I have K2 and K3 are free variables. I'll do this trick. K2 equal 0, K3 equal 1, K3 equal K2 equal 1, and K3 equal 0. What will be K1? In the first case, K1 will be 1, because this will be 0. 1 minus 3 times 0. In the second case, K1 will be what? 0 minus 3 times 1 minus 3. So what are the vectors? I have V1, 1, 0, 1, and V2, it will be what? Minus 3, 1, 0. Which is this one? Okay. Now in this question, he wants the characteristic polynomial. He doesn't want the solution. He wants the characteristic polynomial. So I'll do the calculation. I need just the determinant. Okay, so I have what? 3 minus lambda, 5 minus 2, 0, 2 minus lambda, 0, 0, 2, 1 minus lambda. I'll do the expansion with the first column. I'm getting what? This is cancelled. 2 minus lambda, 0, 2, 1 minus lambda. That will give me 3 minus lambda, 2 minus lambda times 1 minus lambda. That will be what? Lambda square minus 3 lambda plus 2. Let me do the calculation. That will be minus lambda cube, this times this. What will bring me the square? 3 lambda square plus 3 lambda square plus 6 lambda square. Lambda is minus 2, minus 9, minus 11 lambda plus 6. And that is my answer. The eigenvector associated with this is A equal 1. A and 1, find A. Yeah, so I need A V equal minus 1V. So I have A 7 minus 8, 6 minus 7 times A. That will be what? 7A minus 8 and 6A minus 7. That should equal to minus 1 times V, which is minus A, and this is minus 1. So I have 7a minus 8 equal a, minus a, I mean, or 6a minus 7 equal minus 1. Both should give you the same answer. Take this to the other side. So 8a equal 8. So a equal 1. Also the same thing here. 6a equal 6. So a equal 1. It should give you the same answer. So a equal 1. The last one, if the characteristic polynomial of this matrix is this, then a basis for the eigenspace of lambda equal minus 1 is this and this. Yeah, where m plus n. So what they want? They want the eigenvectors for lambda equal minus 1. And I should get 2 eigenvectors. And he put some numbers there and there to find them. So I'll work out this with lambda equal minus 1. So I need to say let v will be k1, k2, k3. I need to solve this. A minus lambda I v equals 0 with lambda equal minus 1. So that will be 6 minus 6, 3. 6 minus 7. Be careful. Minus 7. Minus 1, that is minus 6 also. 3. Okay. This is 6 minus 6. 3. 2 minus 1, that will be 3. That is nice. Equals 0, 0, 0. So I actually have only one equation, which is 6k1 minus 6k2 plus 3k3. Divide by 3. I'm getting what? 2k1 minus 2k2 plus k3 equals 0. So I can say k3 is equal to what? Equal k1 minus k2. Equal k2 minus k1. k2 minus k1. Or you know what? I leave it like this. And then to get an m, now substitute this. This is k1. This is k2. This is k3. And see what will happen. I have 2m minus 2 plus 0 equals 0. So m equal 1. The same thing here. I have minus 2k minus 2. This is 0 plus n equals 0. So n equal 2. So what is m plus n? That is 1 plus 2, which is 3. Yeah, that will do it. Now the remaining is just questions from the book. So let me stop this video. If you notice the old exams, the questions are easier, calculations are easy, and he will ask you about specific things, not finding all eigenvalues or eigenvectors. So because of that, we did it quickly and things went smooth for these old exams questions. So let me stop the recording, and then the next video I will do questions from the book, including suggested problems. Let me stop the recording. Thank you.